Derive the deflection equation with usual notions. First, let us consider the x and y axis. Let curve AB represents the deflection of the beam. PQ is an elemental length of AB. Theta and theta plus d theta are the angle which the tangent at P and Q makes with the x-axis respectively. The normal at the P and Q will meet at point C. Now C is called as the center of curvature of the arc at any point between P and Q. Let ds is the length of arc PQ, r is the radius of arc CP or CQ, then C is the center of arc, and theta is the angle with the tangent at P makes with the x-axis, and theta plus d theta is the angle with the tangent at Q makes with the x-axis. From the figure, PCQ is angle d theta. So the length of arc PQ that is ds is equal to r into d theta. So r is equal to ds by d theta. Let it be the equation number 1. Let x and y be the coordinates of point P. So let us consider this triangle ds and dy and dx, and this is the angle theta, and this is a right angle triangle. So from this triangle only we will do some trigonometry, that is sin theta. Sin theta is equal to opposite by hypotenuse. What is opposite here? Dy, and hypotenuse is ds, and the cos theta is equal to adjacent by hypotenuse. So adjacent is dx and hypotenuse is ds, and similarly for tan theta adjacent by opposite by adjacent. So dy by dx. Let it be the equation number 2. Now differentiating the equation 2 with respect to x. D square y by dx square is equal to differentiation of tan theta is secant square theta, and differentiation of theta is d theta by dx. Now let us divide the ds in both numerator and denominator. The equation will become secant square theta into d theta by ds by dx by ds. Now secant square theta into, let us take this theta and this ds to the denominator, then the equation becomes secant square theta into 1 by ds by d theta into 1 by dx by ds. Now secant square theta, will write it as it is, and by using equation number 1 we know that r is equal to ds by d theta. So we are substituting that here. So 1 by r into, we know that here dx by ds is cos theta, so we will write it down here, cos theta. We know that 1 by cos theta is secant theta, so secant theta. So multiplying secant square theta and secant theta, will get secant cube theta into 1 by r. So d square y by dx square. Now let us send this secant cube theta to the denominator, then it will become dx square by secant cube theta is equal to 1 by r. If secant cube theta is written, we can write it as secant square theta into 3 by 2. And we also know that secant square theta is equal to 1 plus tan square theta. Then we will substitute in that equation dy by dx square by, instead of secant cube theta we will write at secant square theta by 3 by 2 is equal to 1 by r, and d square y by dx square and 1 plus tan square theta into 3 by 2 is equal to 1 by r, and now d square y by dx square, and here when the deflection will be so low, so the theta will be very small, theta will be very small, so we'll neglect the tan square theta, then it will become 1 plus 0 3 by to the power of 3 by 2 is equal to r. Then d square y by dx square, what is 1 to the power of 3 by 2 is 1 only, so we'll not write that, so is equal to r. 30. From the bending moment equation, we know that m by I is equal to E by R. We will send this E to here. M by I is EI is equal to 1 by R. Here here we got the value of 1 by r, so we will substitute it here. 1 by r is d square y by dx square, and now we'll multiply this ei to the other side, so it will become ei d square y by dx square. So this is the equation for deflection of beams. This is the bending moment